Tonight, what I thought we would do would be visit the planet Mars and talk a little bit about some of the things that are actually happening in relation to Mars. So, this talk is called Welcome to Mars. And there's a hint about the way it will develop with the question beneath it: is it our planet B? Is it our bailout planet? Hopefully, by the end of this talk, you will know the answer to that. Of course, that's the usual associate or my affiliation with the Australian government, Department of Industry, Science, Energy and Resources. And I might just mention that there is a connection with Mars, and it's through the Australian Space Agency. You may know that the Australian Space Agency, first of all, it's under the same portfolio as the branch of the Department of Industry that I work in. So it is part and parcel of the same organisation in a larger sense. But it is also, the Australian Space Agency is contracted to NASA to help with the Moon to Mars mission, which is all about humans walking on the surface of Mars. Not next week, but perhaps in 15 years' time. And those are a few university associations that I have as well. So getting straight to the nitty-gritty, here's the solar system, just to remind us where Mars is, what it kind of looks like, how it fits into the grand scheme of things. 4 rocky planets on the left, 4 gas giant planets, well, taking up most of the screen. And then those are the correct size relationship. So they're all properly to scale. Which tells you, first of all, that Mars and Mercury are pretty small compared with Jupiter. But they also tell you that the Earth and Venus are pretty small too. As I often say, we don't normally see them quite lined up as close as that. That's a bit abnormal. In fact, we'd all be ripped to pieces if that was happening. But it gives you an idea of the relative sizes of the planets. I'm going to show you an alternative view of the solar system, which there are people in the world who think it looks like this. Thank you to Neil, who I know is online, for donating this slide. I think it was last year when you passed this over to me, but it has given me a lot of entertainment, mainly because occasionally I do hear from the Flat Earth Brigade, which is another story altogether. But let me now show you this, which is the solar system in a different way. Now, I've tried to eliminate movies as much as I can from this talk because movies are often a bit jerky over the internet, but there are 1 or 2 that I simply couldn't get rid of, and this is one of them. What this shows is all the planets, all 8 planets, not to scale in size, they're all made to be the same size, but what is sort of scaled is, first of all, their rotation. So each one of those models is rotating, and they're all in proportion. So if you look at the Earth, you'll see it rotates once in 23 hours, 56 minutes. The reason why our day is 4 minutes longer than that is that as the day goes by, the Earth moves slightly further in its orbit. So the solar day is 24 hours. But what we call the sidereal day, the orbital period, the rotational period of the Earth, is 23 hours and 50 minutes. You see its tilt is 23.4 degrees. Looking at the other planets, you'll see that they're kind of all over the place with their rotation and their tilt, except for Mars, which is uncannily similar with its sort of 25-degree tilt and its 24-hour, I can't see, it's blocked off on my screen, but I think it's 24 hours, 36 minutes. Its period, which means its day is just a tiny bit longer than that. We call a Martian day a sol, by the way, S-O-L, to distinguish it from an Earth day. But isn't that extraordinary that the planet should rotate in as almost the same time as the Earth does and have a very similar axial tilt, which means that it's got seasons very much like the seasons on Earth. Of course, it's half as far again away from the sun as the Earth is, and so it doesn't receive as much solar radiation, but it does have seasons very similar to the Earth's seasons. So in many ways, Mars has similarities with the Earth. Another one, which is a bit counterintuitive, but one of the other similarities is the fact that the land area on Mars is virtually the same as the land area on Earth. partly because there are no oceans on Mars. It's all dry land. So the two are very, very comparable. Um, One other thing is that when you actually visit Mars, and only robots have done that so far, but when you do, you've got something that looks very like the deserts of the Earth. That is a place called Husband Hill. It's in a crater actually called Gusev crater. I'm going to scan it along as a panorama. Forgive me again if it gets jerky. This image was taken actually, I think, back in about 2005 by the Spirit rover on Mars, a NASA rover, which climbed to the top of Husband Hill, and you can see its tire tracks as it climbed to the top. Did a 3-point turn at the top to get things looking the right way. You can see again the tire tracks. They're not footprints, they're tire tracks. As it looks over this, I think it's about 80 kilometers in diameter, Gusev crater, with the hills on the other side. And the thing that you first notice about Mars, apart from the reddish color, is the reddish atmosphere. It's got that a pinkish color to it. That comes about because of the red dust, which is rich in ferrous oxide, an oxide of iron. It's rust, basically. That finds its way into the sky, so we get this pinkish sky. But otherwise, a very, very Earth-like scene. Now, Mars has a different climate from the Earth because it's further away from the sun, and there are other reasons which I'll touch on in a few minutes. But it's got a colder temperature. Average temperature over the whole planet over the whole year is minus 63 degrees Celsius. There are a few places on the equator where just briefly from time to time the temperature gets above zero, but for the most part, over most of the planet, the temperature is well below freezing. And we'll talk a little bit about that again in a minute. One thing, though, that they do get, that Mars gets, not them, the planet, in the Martian summer, is something that we have here on Earth as well. This is the same scene as what you've just been looking at, but taken without the colour in it. And it's effectively a movie. Now, it will look jerky to you because it is jerky. These are basically a succession of still images. But what this shows is the dust devils on the plains of Mars, these whirlwinds of dust, which here in Australia are often called willy willies, a lovely Aboriginal name for these pillars of dust that form on warm days as eddies of air currents sweep up the dust. I think, honestly, that is such an extraordinary scene because that will have been happening probably for hundreds of millions of years on the surface of Mars. And we are the first to see it. It's just an amazing sight, the fact that dust devils blow across the plains of Mars, despite the fact that it is minus, that's probably minus 20 or minus 30. It was a summer day. The atmospheric pressure is only 1%, a little bit less actually, of the pressure on the Earth. Nevertheless, in spite of these vastly different conditions, we get this phenomenon of dust devils, something very familiar to us on Earth. And the other thing to mention that is different is the humidity is extremely low. There is virtually no moisture in the atmosphere of Mars, virtually none. There is a slight amount, but it's really, compared with what we experience here on the Earth, where a relative humidity of 10% is considered unbelievably dry, Mars is far, far lower than that. Those dust devils are really interesting. Here's a view from above. This is taken with a camera called HiRISE. It's the high resolution camera on the Mars Reconnaissance Orbiter spacecraft. And that's looking directly down on one of these dust devils as it meanders across the plains of Mars. I've seen lots of dust devils here in Australia because when I used to live in Coonabarabran, if you go to the top of Siding Spring Mountain, where our telescopes are, not far from Coonabarabran, and look west, you're seeing out western plains, New South Wales. And in the summer, these things were very common. The tallest one I ever saw would probably have been about 300 meters tall, maybe even half a kilometer. It was really, really tall, quite spectacular. In fact, I took photographs of it. I was so impressed with it. But that's nothing compared with the ones on Mars. Dust devils on Mars can get up to 8 kilometers high. And that's, I guess, mainly due, despite the fact that they've got this low atmospheric pressure, they also or the planet only has about 1/3 of the gravitational pull on the surface that we have on Earth. So there is lower gravity, and that allows these dust devils to grow very, very high. There is another phenomenon actually that comes about because of the dryness of the Martian atmosphere. You occasionally get static electricity being formed by the friction of the dust on the ground over which it's traveling. And so I've seen images which show lightning, little miniature lightning flashes down at the bottom of these dust devils. Really amazing the way physics works in such a different environment from the one that we're all used to. And dust is very much a common feature on Mars, not just the dust devils, but occasionally on a much bigger scale. This is an image from the European Space Agency, taken, I'm pretty sure, with the Mars Express spacecraft, the high resolution camera on board that spacecraft. What it shows is a dust front, a front of dust blowing over the plains of the Arctic, the northern Arctic region of Mars. This was taken April 2018, the year before last. And it actually turned out that during the middle part of 2018, Mars had a succession of these dust storms, but they were really quite intense. And we know from past history that Mars can actually have global dust storms. This is a couple of images taken with the Hubble telescope. The one on the left on a normal Martian day. The one on the right, a couple of years later, I can't see the date because it's blocked out on my screen. I think it was 2003, was it? Doesn't matter. But that was taken some time later when Mars was undergoing a global dust storm. That's something we don't get on our planet, which is just as well. I mean, we do get dust storms in Australia, particularly. We've had a lot during the summer that's just gone by over Western New South Wales, which found their way to the coast. Extraordinary. And in fact, they showed up on satellite images, but not to the extent that the whole planet was blanked out like we found here on Mars. So here's a map of Mars with some of the landers that have actually successfully landed on the planet. And you can see that covers a sort of 30 odd year, 40 odd year history there. The two early ones were the two Viking landers back in 1976, which you can see in Mars's northern hemisphere there. Pathfinder, I think, it was 1999. I think that was the first of the little rovers. Phoenix was 2008, which was landed near the northern Arctic or within the northern Arctic region. It wasn't a rover. I'll show you a picture of it shortly because that made some quite astonishing discoveries about Mars. The really famous ones are Spirit and Opportunity, those two plucky rovers, both of which are defunct now, but they flew to Mars in 2003. They were given, I think, a 90-day lifetime expectancy. They were still going, one of them anyway, was still going more than a decade later. I think 13 years was how long Spirit lasted. Now, however, not operational. Curiosity landed in 2012 and is still active, and we'll see more from Curiosity shortly. InSight, the one that's highlighted there, because this map was made just after InSight landed in 2018. That is a spacecraft that's designed to sense some of the Mars quakes, actually, and to look for the heat loss from the interior of Mars. It's not a rover. It's actually based on the same chassis as Phoenix. The two are very, very similar, but they do quite different things. Here's another version of that, courtesy, of course, of the BBC, as you can see in the bottom corner there. What else has landed on Mars? Well, there have been one or two that have had less than successful landings. And I'm not going to go through them in detail. I might just mention Beagle 2 because that's an extraordinary story. As you can see, Beagle 2, a little to the right of centre there, I always describe it as a terribly British mission, not just because the BBC's down at the bottom, but Beagle 2 was the product of scientific enthusiasm in the United Kingdom with a budget, I think, of about £2 million or something. It was very small, but they hitched a ride on the Mars Express spacecraft, which was a European spacecraft, and it was jettisoned from Mars Express. Mars Express remained in orbit. Beagle 2 went down to the surface to land, but sadly was never heard from. And the assumption always was that it crashed. But about 4 years ago, I think, we got evidence from the high resolution camera on Mars Reconnaissance Orbiter. The high resolution camera showed the debris, not the debris of the crash, the debris of things like the aeroshell, which is what protects the spacecraft, the little Beagle on its way down. And the problem with Beagle was not that it crashed, it landed perfectly safely, but its solar panels didn't unfurl properly. And so sadly, we never got the signal that said, I'm here. And now we know that it did make it, but not in the way we expected. Just one other to point out, Mars Polar Lander down at the bottom there, a NASA mission which crashed on the surface of Mars. And about the same time, there was a spacecraft called Mars Climate Orbiter, another NASA spacecraft that also didn't make it to the surface of Mars. I think that was the one that suffered because of a mix-up of the units that were being used between imperial and metric at some point. I might have that the wrong way around. But those two missions, essentially, I think they caused totally unjust criticism of the space agency. And this cartoon kind of has been going around since then. NASA in the news. You can see that if NASA does something cool or finds alien communication or makes a big discovery, percentage of topic in the news 0. But if something blows up or they need money, it's 100%. That's, of course, an exaggeration. It is a cartoon from Graph Jam, as you can see down at the bottom. But it does reflect a feeling, particularly in the United States, that NASA is an expensive luxury. To be honest, it's not that expensive, but in global terms. But that they play around with all these spacecraft, and when things go wrong, everybody's up in arms about it. I'm a big fan of NASA. I think what they do on their budget is absolutely astonishing. It is mind blowing. Time to talk about that this evening, but I do think that's very unjust. I'm always glad to see that there are people out there who are connected with NASA who retain a sense of humor about all this. This is an image from the Pathfinder mission back in 1999, and somehow there's the golden arches have appeared there. Let's just take a closer look, though, joking aside, at the surface of Mars in some detail. And this is, again, actually, it's a Mars Global Surveyor image. So not an image. This is the result of literally surveying the surface of Mars. That spacecraft, I think, is no longer active, having been replaced by Mars Reconnaissance Orbiter. Once again, a NASA spacecraft. But you can see the detail on that map of the surface of Mars. Of course, it's a topographic map, with blue being the lowest regions and red and white being the highest regions of Mars. And the two polar regions, the North Pole and the South Pole, are shown there at the right. If your screen is good enough, you might be able to see the scale of heights at the top. The heading at the top, if you can't read it, is the topography of Mars by the Mars Orbiter Laser Altimeter, or MOLA, which used a laser to probe the heights above a datum point on the surface of the planet. A number of features to point out here. That huge blue splodge in the sort of right center, lower right center there, is it's a very large impact basin. Impact basins are what we see on the moon when we look at the grayish areas that you can see with the unaided eye. Looking at the moon, you see impact basins like that, but they've been filled in by lava flows afterwards during a period when the moon underwent volcanism about 3.5 to 4 billion years ago. That impact basin there on Mars sort of flies in the face of what you can see around it, which is highland country, pockmarked with lots of craters. There is another impact basin to the left of center there, but look up at that reddish region, which is clearly very high in the left of the map. That is the Tarsis Rise. It's an area which is a bit of a bulge in Mars's landscape. And it's pockmarked by what are very prominent there. You can see four of them. There are more, but these are volcanic cones. They're actually shield volcanoes, rather like the volcanoes of Hawaii, which are shield volcanoes. And they are very, very large. In fact, the one on the left is Olympus Mons. That's the biggest pimple, the one that's slightly off the red region. Olympus Mons, the area you can see that it covers there is about the size of France, a little bit smaller than the size of France. And its height from base to top is 22 kilometers, which is, it beats the 8 kilometers or 9 kilometers of Mount Everest. And our biggest volcano here on Earth is actually Mauna Kea. It's the big island of Hawaii, which, if you measure it from the seabed, which is where it started from because it's volcanic, is about 10 kilometers high. And so it's more than twice the height of Mauna Kea, an enormous volcano. In fact, the biggest volcano that we know about anywhere in the solar system. There's another story as to how those volcanoes might have come about, but it does link in with one thing I'll say now, just to foreshadow one of the things I'll talk about in a few minutes. Mars does not have plate tectonics. Unlike the Earth, which has crustal plates that shift around over geological time, Mars doesn't. And that is the reason why those volcanoes got so high, we believe, that there was a hot spot underneath the surface crust, but the surface crust never moves around, so the hot spot just stays underneath and bursts through, and the volcanoes erupt and erupt and erupt and keep on erupting, so they grow very large. What I also want you to notice is the fact that the top half of that map is quite different from the bottom half. The upper region is blue, it's low-lying, it's very, very flat. Where are all the mountains that you see in the lower half? They're not there. Neither are the craters. There are craters in the northern half of Mars, but far fewer. And what that tells you is that you're looking at probably a younger surface than the surface south of the equator, the Martian equator, because cratering is something that happened, actually much of it happened very early in the history of the solar system. The solar system is 4.6 billion years old. And at about 3.8 billion years, there was stuff charging around all over, which is when many of these basins were formed. But then things quietened down. And what that's telling you is that that northern part of Mars is probably a more recent surface. And that's one of the reasons why, and there are many others, but it's one of the reasons why we think that early Mars actually had a northern hemisphere which was essentially covered in water. Now, it may have been an ocean, it may have been a succession of seas, it may have been short-lived, by that I mean a few million years, or it may have been long-lived, by that I mean a few tens of millions of years, maybe a few hundreds of millions of years. But we do believe that Mars's northern hemisphere, sort of 3.8 to 4 billion years ago, was actually wet, that it was covered in water. There are all kinds of other reasons for believing that, mainly to do with things like coastal erosion features, things like sea cliffs, estuaries, all of those things that speak of basically a shoreline. So that's an interesting aspect of Mars, and it's one that fascinates planetary scientists. Mars was clearly once warm and wet. So there are a number of questions about that. And the first one is, well, what's happened to all the water? Did it just go down the plug hole? The answer is no, it didn't. In fact, a lot of Mars's water is still there. But because the temperature is so low, it's frozen. So we can see some of it on the surface. This is a Mars Express image of a crater, I think about, if I remember rightly, about 30 kilometers across, near Mars's North Pole. And in the center of it is what looks like an ice rink, and that's because that's what it is, a very big one, slightly bulged actually, just because of the expansion of ice as it cools. But that is water ice. The stuff, if I remember rightly, the stuff that you can see around that upper right-hand edge of the crater walls, I think that's carbon dioxide frost. But the stuff in the middle is not carbon dioxide, it's water, frozen solid. And then to add to our knowledge of water on Mars, back in 2008, I mentioned already, a little spacecraft called Phoenix was sent to the Northern Arctic. You've already seen where it landed. This is a picture of Phoenix taken using its own masthead camera. All these rovers and landers can take selfies of themselves. It's brilliant stuff because they've all got cameras on board that are on robotic arms that can move around all over the place and can do things like this, like you take a selfie of yourself. So that's a Phoenix selfie. The two strange looking umbrella-like things on either side are not umbrellas, of course, they're solar panels. Phoenix really was simply a platform with instruments on it, but one of the things that it boasted was a kind of backhoe scoop that could reach down and scoop away the soil, the surface soil of Mars. It couldn't move anywhere. It was simply in the same location. It's now long defunct because it's been covered in ice several times since then, but did a marvelous job. And these two images show what it found. So that's the backhoe scoop scraping away the surface down to a depth of only a centimetre or so, maybe a little bit more. And you can immediately see that there's something white underneath. Now, if you didn't know anything else, the things about it, you might think that was some sort of rock, but it's not. It's actually water ice. And there is evidence for that already in this pair of pictures because they were taken about three, if I remember rightly, about 3 Martian days apart. Look at the left-hand one and look to the lower left-hand edge of the backhoe scoop's imprint. And you can see little chunks of stuff that aren't there in the right-hand one. And what they are is lumps of ice. The left-hand one was taken just after that scoop had been made. A few scrapes of ice came off, sat in that lower left-hand corner, but they're not there on the image 3 days later. And that's not because somebody's come and taken them away. It's because they have actually, well, the technical term is sublimed. You might think of it as evaporation, and in a way it is evaporation, but it's evaporation directly from a solid rather than going through the liquid phase. So ice on Earth doesn't sublime, it turns into a liquid. That's partly because of the atmospheric pressure. Well, it's mostly because the atmospheric pressure is high enough to keep a liquid stable. The atmospheric pressure on Mars is too low for that to happen. So solid ice goes straight into a vapor, so it's vaporized. That, of course, the fact that it was ice has been confirmed because Phoenix carried all kinds of analytical gadgets. So the ice was analysed within the chemistry laboratory on board on board the spacecraft and proved to be water ice. But Phoenix found something else as well, which is that some of that water ice was rich in perchlorates. Perchlorates are chemicals that act as a natural antifreeze. And in fact, they can lower the melting point of ice down to about, I think it's about minus 76 or thereabouts Celsius. It's very, very cold. There is some evidence of there having been liquid water for a while on the legs of the Phoenix lander, thought to have been liquefied when the spacecraft when its exhaust was firing and blowing away the surface sand and revealing the ice, and then condensing back on the legs. A couple of images which I remember that showed droplets running down the legs, probably not for very long, but they would have been rich in these perchlorates, these natural antifreezes. So a summary here, you don't need to read all this, but this is just our understanding of the amount of water that there is on the planet Mars, but it's locked up. We now know that there are immense quantities of water within Mars, mostly under the surface. The polar ice caps are a mixture of water ice and solid carbon dioxide. One European Southern Observatory, one European Space Agency, an inadvertent plug there for the European Southern Observatory, with which Australia has a strategic partnership now. The European Space Agency made an estimate some years ago that there was enough water just within the southern cap itself. If you melted it all, would flood the whole planet to an average depth of 11 meters. So there is a lot there. And if you've been reading through any of the things on there, you will know that there is a lot of water on Mars, but it is frozen. In fact, recently, actually, well, it's a year and a half ago, or nearly 2 years ago now, radar on board. Let me think. I think it was again Mars Express, carrying kind of ground penetrating radar, although it was an orbiting spacecraft, actually detected a body of liquid water, a large lake effectively of liquid water under the southern polar cap, which of course has everybody excited because liquid water here on Earth, wherever there's water, you get life. Let me move on, or let me just mention one more thing before I move on. There is, as I've mentioned, because of these perchlorates, there are times when you can have liquid water on Mars today. Occasionally, the temperature gets high enough that water can flow. This is an image just of a rocky outcrop that's got evidence, as you can probably see, of something flowing off the surface as the surface heats up. It is probably water. That's not guaranteed, but that's thought to be the source of those things. So Mars, in summary, a world with similarities and differences from our own, but one that is tantalizing. We've always loved the idea of Mars. We thought for a long time that there might be canals and vegetation on Mars. That was all dispelled in the 1960s. But we're still in love with the idea of visiting Mars. But some people are in love with it even more so because they wonder whether it could be our planet B. In other words, if there was, if we should be preparing for a global catastrophe on our own planet by setting up shop on the nearest planet most similar to Earth, which of course is Mars. So very briefly, let me take you to, okay, why did Mars freeze? I'm sorry, I forgot to add this one in. All right, why did Mars freeze? Forgive me, I'll take you to doomsday in a minute. Let me just explain perhaps briefly why the planet froze. And here's one of the sketches that I did for Cosmic Chronicles explaining, and it's all about plate tectonics. There is this process that takes geological time, but nevertheless is a real thermostat on Earth. And it's because the Earth has plate tectonics. What that does is it actually recycles carbon dioxide between the crust of the Earth and the atmosphere. And as I said, it acts basically as a thermostat. It gives the Earth a greenhouse blanket, which, despite everything else, is something we need. We need that carbon dioxide in the atmosphere to stabilize the temperature. And you get an idea from my crude sketch there of the process that you have volcanoes erupting carbon dioxide into the atmosphere that either reacts to form carbonic acid or falls directly to the bed of the ocean as carbon dioxide, forms a crust on the oceanic plate, which is ducking underneath the continental plate. That's what happens in plate tectonics, and basically transporting carbon back to the roots of these volcanoes where it all starts again. And that is thought to be just one of the processes that stabilizes the carbon dioxide content of the Earth, but a very important one. Now, as I've said already, Mars doesn't have plate tectonics. Why doesn't it have plate tectonics? Probably because it's too small. You need a reservoir of heat in a planet in order for that to take place. The whole process of plate tectonics on Earth is driven by essentially convection currents within the mantle, which is the layer underneath the crust. Mars doesn't have the necessary oomph in those convection currents to drive surface plates around. And so we think that if there was a carbon dioxide cycle like we have on Earth, on the early Mars, that may have been what kept it warm and wet. But losing that as any plate tectonics died away, and they may have been early in Mars's history, losing that meant that you lost the carbon dioxide, planet lost its greenhouse blanket, and froze, essentially. There is another aspect as well. Mars does not have a magnetic field like the Earth's. Its core is probably not once again, as energetic as the Earth's to generate a magnetic field. And so that too has contributed to the stripping of the carbon dioxide by the solar wind simply interacting with the upper atmosphere of the planet. On Earth, we have a magnetosphere, which actually envelops the Earth. That prevents the subatomic particles from having too much of an effect on the Earth's atmosphere. Although, of course, near the poles, we see that effect as simply as the aurora borealis and the aurora australis. So let me take you from the Mars that we know and love to what some other people would like it to be. I want to take you to doomsday scenarios, because we have to talk about this when it comes to Mars being our lifeboat. And the first thing I'd like to ask is, well, is the human race worth saving? And that's a really interesting philosophical question, which we don't really have time to dwell on this evening. But I might make the point that you can ask the question, but question, no pressure at all. Now, we don't know that, of course. That's another talk about the likelihood of intelligent life elsewhere in the universe. There are pros and cons for the debate as to whether that should be. I think the astrobiology community these days leans to the idea that intelligent life is incredibly rare. And that puts a bit of responsibility on us, because we might be the only species here to to look at the universe. So I actually believe the human race is worth saving, and I'd like to help in any way I can. So, having said that, what are the possible threats to human life? What are the things that could wipe us out? And they fall into two categories: the stuff we do to ourselves, and you all know what they are. I'll just put them up there: climate change, overpopulation, global war. These all have they all have solutions, uh, technological solutions, which in some cases are not as difficult as they might seem. Um, um, you need a few grown-ups in charge of things in order to make them happen. But these are all tractable, and in fact, overpopulation is one that I think some of the economists for many years have been looking at the global demographics and suggesting that our population, the planet-wide population, will peak around about the middle of this century, maybe a little bit later, but with around about 10 billion, maybe a couple more billion people on the planet than that. But with proper management, all that is quite sustainable. And then it starts going down, because that's what always happens with the demographics of populations. So I'm optimistic about the way we can handle all those things. Stuff over which we have no control is slightly different, and you probably know what they are. And this is a bit interesting, because I put this slide together last year, but of course the number one item on that is a runaway virus. How extraordinary! That is exactly the reason why these webinars have come into place, the Cosmic Relief webinars. Yes, with a virus that is more dangerous and with perhaps less management than we've seen with the COVID-19 epidemic, that could be a threat to humanity. There are other more physical ones. A supervolcano, we know that in the past the Earth has had supervolcanoes. I've got a version of this talk which is much longer, the doomsday scenarios, in which I talk about the various supervolcanoes that have actually erupted. The last big one was about 70,000 years ago in Indonesia. But there are places where we know that there are supervolcanoes potentially able to release their energy if things turned out that way. Killer asteroids are another one that we often think about. We know that's what got rid of the dinosaurs. There have been other mass extinctions throughout geological history that were probably caused by killer asteroids. And well, the last one is, a nearby exploding star. Let me just say that the first three of those, I think, are all manageable. Volcanoes and asteroids now are monitored. We have, the Earth is festooned, well, not quite festooned, but there are many telescopes which are looking for near-Earth objects. We have a mandate from the US Congress towards NASA to find everything down to a size of 140 meters across, which is citywide devastation, but certainly not global devastation if one should hit. Things the size of the dinosaur killer are a lot easier to find because they're bigger. These things, that one was about 15 kilometers in diameter. Likewise, volcanoes are now monitored with highly accurate seismometric equipment, global positioning uh, points on the sides of the volcano to deduce when they change their shape. At the very least, we could probably make educated estimates of when a supervolcano might blow and get people out of the area. It might have a long-term effect on the climate because you get lots of dust going into the atmosphere. But that, once again, is something that I think we could manage. The last one is really the one that could get rid of humanity because, and it doesn't matter where in the solar system you are, if there's a nearby supernova goes off, you get fried anyway. The nearest star that might look as though one day it could be a supernova is in the constellation of Orion. It is Betelgeuse or Betelgeuse, depending on how you say it, 700 light years away. When and if it does finally turn into a supernova, then it will be as bright as a half moon, essentially as the moon at first quarter or last quarter. But it won't fry us. It's far enough away not to. And within that range, there is nothing that has the symptoms which we believe supernovae show before they actually detonate. So I think we are in reasonably good shape. Now, that's the famous last words, but I think we are in relatively reasonable, given the things that we can control, given the grown-ups taking charge, we could survive. Nevertheless, there is still a body of opinion that says, well, should we try and make Mars our planet B? Perhaps with its atmosphere modified to be warm and wet again. This is a lovely artist's impression of what Mars might look like. Maybe it looked like this 3.8 or 3.9 billion years ago when it had oceans, but it doesn't look like it now. And so that leads to the idea of terraforming Mars. Terraforming means make it like the Earth. How do you do that? You shovel lots of carbon dioxide into its atmosphere. These are 4 stages in that process taking place. Maybe the carbon dioxide could come from the polar caps, which are made partly of solid carbon dioxide and partly of, as we've seen, of water ice. If you evaporate them, you get water vapor in the atmosphere, you get carbon dioxide in the atmosphere, and maybe that starts to warm things up. It's a very delicate game that you're playing here, tinkering around with a planet. Another suggestion has been to smash an ammonia-rich asteroid into Mars, which we, of course, by the time this all becomes reality, would be capable of, and letting it do the job for you, putting carbon dioxide into the atmosphere, which might give you somewhere livable within 1,000 years or something of that sort. My message, though, to anybody who's enthusiastic about that is that, unfortunately, it doesn't work. And that is because, and this is a complicated diagram, I don't really have time to talk about it in detail, but if you look at the middle-ish of the diagram, you can see something labeled current temperature on Mars, and to the right of it is Mars with an Earth-like temperature. What this is telling you is that Mars actually can't hold on to the things that make the atmosphere Earth-like because it's too small. It's the same problem. Mars can't hang on to the oxygen, the nitrogen, at least at the temperature that we could live in. The atmosphere doesn't work, and plus the fact that it doesn't have this global magnetic field. So you've got the problem not only of the atmosphere being stripped, you also have the problem of radiation on the surface of the planet. It's really not going to happen. Nevertheless, there would-be colonists who aren't deterred by that, and maybe I can just talk about a couple of them. He is a gentleman by the name of Bas Lansdorp, who's Dutch, and in 2011 founded a company called MarsOne, which you may well have heard of because it had enormous publicity. The idea of MarsOne was to colonize Mars with one-way trips to the planet. In other words, you pick people who'd like to go and spend the rest of their lives on Mars and not come back. In fact, he had ambitions for this to be happening. Initially, it was going to be 2023, 3 years from now. It was going to be funded by reality TV. And that was, of course, all the people who do space economics and things of that sort, within a month of the announcement, which was actually early in 2012, of this company, they immediately leapt on that and said that simply doesn't work. Bas Lansdorp's estimate of the cost of this, the initial costs was 6 billion euros, I think it was, rather than US dollars. Um, and the, the pundits pointed out that that is, first of all, about 10 times more than you could raise by reality TV, because reality TV really doesn't keep big audiences for very long. And it's also about 10 times less than what it really would cost. It's more like 100 billion. It's probably more like 15 times. So it was already, the writing was already on the wall right at the beginning that this was not going to work. Nevertheless, it got lots of media hype, in particular because the media like to interview people who are so sick of life on Earth that they want to spend the rest of their lives on Mars and not bother coming back, which of course would make for interesting reality TV for a while, but it also made for interesting newsworthy TV. It attracted around about 2,700 people, and I've put misinformed there because I think the MarsOne people knew they were onto a loser right from the beginning, simply because the finances don't add up. The claim was that they had 2,000 applicants, but that was since actually withdrawn by Bas Lansdorp himself. It was more like 2,700, which was whittled down by a process of really, I don't think it was all that rigorous, but it looked as though it was being rigorous, candidate selection. Down to 100. And I think by the time it got down to 100, these people really believed they were going to Mars, really sadly. But basically, the writing was on the wall very early on, and the project was dissolved. In fact, it went bankrupt at the beginning of last year. So, a really interesting story, and maybe more interesting from the point of view of the psychology of the whole thing, how you can attract people to the idea of going to a planet and never coming back. To live in enclosures like the ones at the bottom, which were derived from SpaceX facilities. It's a very interesting and in some ways slightly tragic project, which is different from the next one I want to talk about. You might recognize the gentleman on the left, Elon Musk, who is the CEO and actually might not be the CEO, but he's certainly the founder of SpaceX. Now, I have to say that I'm a big fan of Elon because of this. And I take every opportunity I can to show this footage, which is the astonishing breakthrough that he has made. SpaceX and all the people who work for him have learned how to bring booster rockets. Instead of letting them drop into the sea and rot on the ocean floor, they bring them back to Earth and land them either on the ground or on a barge like this one, heaving away in the North Atlantic. That is such an extraordinary achievement. It really speaks volumes for the capabilities of SpaceX. And the interesting thing is, this was dazzling about 3 years ago. It's now absolutely routine. They've done this more than 50 times now. And it's really, amazing stuff. One thing I love about Elon is his sense of humor. That barge is called, Of Course, I Still Love You. There is another one with a different name, which I cannot remember, but I like the idea of Course, I Still Love You. Here is Of Course, I Still Love You being towed back to Florida with a booster rocket on the back, the first stage of the Falcon rockets, actually on the platform, ready for reuse for a further time. I'm not sure what the record for reuses is now. It's probably 5 or 6 for a given booster. It might be more than that. So this recycling of the resources is something that, first of all, is very sustainable, and secondly, brings the price of space flight down. So, as I've said there, you really have to admire the technological achievement. Extraordinary stuff. Now, Elon is not so without ambition. So back in February, can't see the date, but I think it was 2018, there was the launch of the Falcon Heavy, which consists of 3 of Elon's Falcon boosters sort of strapped together to be able to take, there it goes, a mass of about 64 tons into low Earth orbit. 64 tons is the weight of a small locomotive. It's extraordinary. And so that is the capability of a spacecraft like that. And in fact, I think there's certainly been at least one other launch of Falcon Heavy since that maiden flight couple of a couple of years ago. But as I said, Elon is not without ambition, and what he envisages as his kind of flagship project is the Starship, which has nearly 3 times that lifting capacity. It's 150 tons to low Earth orbit. Here is a diagram showing what Starship looks like. On the left, you have the Apollo era Saturn V rocket tower. On the right is a standard Falcon 9 rocket of Elon's fleet. But Starship is a remarkable project, which is, engineering on a gigantic scale. And the idea is to take lots of people into space, as well as servicing things like the International Space Station with very heavy loads and servicing other spacecraft. But the bottom line is that Elon has his eyes on Mars. Starship, I beg your pardon, is not something that is a figment of imagination. It actually exists, hasn't flown yet. There was recently a pressure test on one of the main structures for the Starship, which sadly came adrift. The thing didn't survive. It was a cryogenic pressure test, so very cold and high pressure, and something went wrong with one of the end barriers on the Starship module that was being tested, and it collapsed. There's some quite exciting footage of that on the web. But what Elon has in mind is using these things to transport people large numbers at a time to the planet Mars. Now, let me say, we have not yet solved the problems of getting humans to Mars. NASA are working on that, of course. NASA anticipate that it will be the mid-2030s at the very earliest before they have a crew walking on Mars, humans walking on Mars, and it may well be an international, I hope it is an international body of people, just like the way we run the International Space Station. But Elon wants that all to happen much more quickly. I don't think a lot of the problems have yet been solved, but certainly Starship is going ahead, and of course it would have uses in Earth orbit as well. But his ultimate vision is for this, for families of these giant spacecraft to ferry people to the planet Mars and to set up colonies on Mars, despite the fact that we know there's a radiation hazard, so you have to build them into sort of pods that look a bit like that from above, where people live and work, which provide an environment that's as similar to Earth as you can get, notwithstanding the fact that the gravity is only 1/3. So my question, however, about that is, have you asked the Martians? Now, we don't know whether there are any Martians, but given what Curiosity has found and what we might hear about soon, maybe there are species of microbes on Mars. Here is a Curiosity image showing a region of, these are mudstones. These are stones that were laid down as clay at the bottom of a lake bed, demonstrating that, yes, Mars was once warm and wet. Now, we know that life thrives in every environment on the Earth. So the question is, could it also thrive on Mars? And that means, should we be ferrying large numbers of people to tramp all over the planet? Because the question is, did or does Mars harbour life? A very brief word, because we're running out of time here, about the kind of life that we might be talking about. The extremophiles are basically organisms here on Earth that love extremes. This is a molecular map of an extremophile. It's basically a bacterium called Deinococcus radiodurancis, which can withstand 3,000 times the lethal dose of gamma rays for humans. This thing just soaks up the gamma rays. Give me more. And it's not just gamma radiation that some microbes are resistant to. There was an experiment done actually a number of years ago, taking some microbes from a place called Beer, which is in Devon in England. Experimenters basically just grabbed some rocks from the cliffs of Beer, which you can see in this image, and took them and their microbes to the International Space Station. This was back in 2008. And they were random microorganisms. They weren't specially selected for their durability or anything. They were just random microorganisms plonked on the outside of the International Space Station for 553 days, brought back to Earth to see what happened. And as it says there, significant fraction remained viable when they were, rehydrated. So microbes can withstand the environment of space, as can this little critter. This is not a microbe. This is an animal. This is the great, good old tardigrade, the water bear. All of a millimeter in length, sometimes less, sometimes more. Very, very common, 1,000 species of these microscopic organisms. But they're animals, not microbes. And there was an experiment in 2007 that showed that they, at least a significant number of them, could survive being on the outside of the International Space Station. I think they were mostly shielded from the ultraviolet radiation from the sun. These things, what they do, they dehydrate and curl up into a ball, which is called a ton, if I remember rightly, TUN. And then when they're rehydrated, they kind of just carry on as if nothing had happened. It gave Nature the lovely headline, the science journal Nature, for these creatures, spacesuits are optional. But it's because of things like this, the microbes and the even animals that can withstand space, that when you send a spacecraft out into the solar system, it has to follow the planetary protection rules. These come from the Committee for Space Research, COSPAR, and they are enshrined in law, in space law. And what they say is you have to protect wherever you're going to from earthly microbes, and you've also got to protect the Earth from anything you might bring back. And that's something we have to face down the track. I think we haven't faced it yet because things that have been brought back have come from sterile worlds like the moon and an asteroid. But there is one category of sterilization. There are, I think, 6 categories, if I remember it rightly, in the planetary protection rules. Category 4C says that's for going to Mars, places where the temperature could get above zero. 30 spores per spacecraft. That is the level of sterilization. This shows Curiosity, before it was launched, being sterilized, and that adds a significant cost to the mission. In fact, it's quite significant, the sterilization process. It does beg the question: what happens when humans go to Mars? I don't have time to address that here, but clearly the rules have to change. So sterilization is important, and whether there's life on Mars or not is really interesting. But there are hints here on Earth from what we've already seen, that maybe there was life on Mars, even if there isn't. This is a picture of a place called El Tatio. It's in northern Chile. It is the highest geothermal area in the world. There are geysers there. Well, not quite geysers, they're geothermal ponds. You can see the steam rising. It's at 4,300 meters. You can hardly breathe up there, but it is a stunning place. We were up there a few years ago. What is interesting, though, is that these geothermal ponds actually lay down microbial mats, and they eventually turn into rock. In fact, they turn into opaline silica. And ones that have been found on Mars by the Spirit rover have exactly the same appearance and spectroscopic characteristics in the infrared to deposits found at El Tatio. It was a paper published back in 2016. It doesn't prove there was life on Mars, but it's one of many things that just builds up the idea that perhaps Mars did have life on it. Actually, in this abstract, the authors close by saying, although fully abiotic processes are not ruled out for the Martian silica structures, they satisfy an a priori definition of potential biosignatures. In other words, it might be life. So there might have been past life. There might be present life too, because there is this extraordinarily interesting phenomenon of the methane outbursts on Mars, in Mars's atmosphere. Methane is something that doesn't last long in an atmosphere. The sunlight radiation breaks it up. So the question is, where's it coming from? Is it volcanic activity, or is it methanogenic organisms, organisms which actually release methane? And so that could speak of microbes that are there today. They may be under the surface, out of the radiation hazard. But what we're going to do very soon, I hope, is find out. Here it is, was designed to show whether Mars was ever habitable. It did, and yes, it was. But its successor, Perseverance, now under test and due for launch later this year and is still on track, that is designed to sense whether Mars ever had life, rather than was it ever capable of having life. Perseverance, very similar to Curiosity, but with different scientific experiments on board. A week ago, one of the interesting aspects of Perseverance was loaded onto it, and that is a helicopter. This is carrying the first extraterrestrial drone, which is seen folded up there. It's actually on the underside of the rover. The rotors of the drone are about, well, they're 1.2 meters in diameter. It's like a big ceiling fan, but with the blades rotating in opposite directions to keep it on board. There's the underside of Perseverance, taken, as I said, about a week ago, showing the drone actually attached to the underneath. It will be cocooned there after the rover lands on Mars in February next year, all being well. There'll be a couple of months of proving before the helicopter is released. But the bottom line is, there may be life on Mars. We simply don't know the answer to that. And that's why I think it's a little bit premature to be thinking about colonizing a planet that might have its own indigenous life, that could in a few billion years turn into species like ourselves to ask questions like this. So just winding up, I think, yes, humans, I'm not a Luddite when it comes to this. I think humans should explore Mars. I think it's very important to do that. But I think colonization, no. Maybe, just maybe, one day we might have tourism on Mars. And that, I think I've shown that Antarctica there in that last slide, because I think that's a good model for how we should deal with Mars. One day tourists might like to go, as they do to, well, as they used to Antarctica today, and watch the beautiful blue sunsets on Mars, because sunsets on Mars are not pink, they are blue. So for the time being, however, I think let's leave Mars to the explorers rather than the colonists and the tourists. And that's the end of the talk. I'm sorry I've overrun my time again, but I hope you will bear with me and you haven't all disappeared offline. Thanks very much, everybody, for attending. And we are open to questions if you have some.
Yay!
Oh, thank you, Marnie.
Thank you. Oh, I've woken the cat up. Here he comes.
Okay.
Fred, I have some questions. There he is. There's Mandu. I might turn my video off because you don't need to see me. But Fortini has asked, and a few people have asked if you could answer this question. Is there a reason why most missions focus on landing in the northern hemisphere of Mars?
Yes, that's a really good question. Actually, if you look carefully at the map, most of them are not too far from the equator, but rather north of the equator. And one reason for that is simply the topography. It's the fact that Mars has a much gentler landscape in its northern hemisphere. And if you're going to land a spacecraft, honestly, landing a spacecraft on Mars is by no means a doddle. It's a very tough gig, and that's why there have been several failures, as you saw on the diagram. So you want to make it as easy as possible, but you also want to make it as scientifically productive as possible. So the plains of Gusev crater were chosen for Spirit. It's Gale crater, in which the Curiosity lander has been working. So crater bottoms are fairly flat, but in the southern hemisphere there is much, less welcoming terrain. And I think that's the main reason. Plus the fact that people try and get the biggest scientific benefit out of their bang for their buck, and so they will go to what are seen to be the most likely places. And just one postscript to that. Of course, the northern hemisphere was once wet. It's where the ocean was, if there was an ocean on Mars. So that is the place to go to look for perhaps fossilized microbial remnants, as well as being the easiest place to land. Thanks very much, everybody, for that question.
Okay. There's quite a few questions here, but the other one there's a couple that have been voted on by the audience, so they're the ones I'm going to ask. They always say that if you've got water, you can get fuel and oxygen, hence H2O. But can it realistically easily be separated to H and O and used? And has this ever been tested away from Earth? Asked Swez.
Yes. I think the answer to the last part is it's not quite no, I don't think, because I suspect this. There are two processes here. there's one called electrolysis, which is to use electricity to separate water into its constituent components of hydrogen and oxygen. And that's well tried, well tested, has been known about for 200 years, and it works. And of course, on Mars, you have not many clouds. There are clouds in the Martian sky, but not enough to deplete the solar radiation. You've got, so if you have solar panels, you've got really a very ready source of electrolysis to do the separation. The process reversed is actually a fuel cell, and in a fuel cell, you use oxygen and hydrogen to generate electricity. And that was the problem with Apollo 13. It was the fuel cell that went wrong. I don't think there was an electrolytic converter on Apollo 13, which would be electrolysis taking place off Earth, but I might be wrong there. It could have happened off Earth. Basically, the process is, it should work anywhere, though. It's not something that depends on gravity.
Okay. I like this question from Rosalind. How did Husband Hill get its name?
Oh, that's a brilliant question. And thank you very much for asking that. Husband Hill. So the range of hills in which Husband Hill is just one. They're called the Challenger Hills. And that might give you a clue because they're named after the Challenger space shuttle, which was lost in 1986. One of the astronauts on board, I can't remember his first name, it might have been Rick, but his surname was Husband. So all the hills are named after people who lost, astronauts who lost their lives in the Challenger disaster. Isn't it? It's a poignant reminder of the fact that spaceflight is not easy, that things can go wrong.
Graham says, yes, it was Rick Husband.
Oh, that's great.
Right. What have we got time for? Hamish Barker says, you mentioned that Mars was not geologically active, but what about Cerberus fossae?
Yeah. Clearly it was geologically active because there are volcanoes there. There are remnant volcanoes. So perhaps if I said that, I used the expression wrongly. Maybe a better way of putting it would be that Mars, at least today, is not tectonically active. In other words, that's saying the wrong thing. It doesn't have crustal plates that behave the same way as the ones on Earth do. However, there is some evidence that there may have been in the past because, and once again, I'm dredging up things from reading a long time ago here, but there are Mars, as I said, doesn't have a global magnetic field anything like as strong as the Earth's, but there are places on Mars where you find lines of enhanced magnetism, linear features on the surface of the planet where the magnetism is higher. And one theory is that what you're seeing there is the boundaries of essentially extinct tectonic plates. You're seeing the fossil remains, in a way, of where there used to be tectonic plates, and they have now stopped moving around because of the lack of a heat source, and basically the whole thing is just solidified into a solid crust. That would have happened very early on, though, in Mars's history, I think.
Okay. Neil actually makes a comment, which I think is a good one. We should be promoting the experts working for Musk, not just Elon himself.
Yes, absolutely. That's why I mentioned, everybody else in the company, and they all work hard. They are inspired by what they're doing. It's not just SpaceX, it's Tesla as well. But the idea of doing things in a sustainable way here on Earth, I think, is absolutely laudable. My question is whether that directly translates to Mars before we really know as much as we'd like to about the planet Mars.
And Amanda just asked a quick question off the back of your last question. Is Earth the only terrestrial planet that has plate tectonics?
As far as we know, that is true. It's a bit more difficult to ascertain with Venus, because Venus has been volcanically active in the past. It's actually got more volcanoes. As far as we know, they're mostly or even all extinct, but it's got more volcanoes than any other body in the solar system, including the most volcanically active, which is Jupiter's moon Io. So Venus might have plate tectonics, but I think it's the feeling among planetary scientists, I think, is that it probably shut down like the ones on Mars as well. Venus is a vastly different place. Of course, it's nearer to the sun. It's got a much different, characteristic in terms of its atmosphere, 100 times the pressure on Earth, very hot, 470 or thereabout, 465 degrees Celsius, but maybe different, quite different geologically. We really, of all the inner planets, in many ways, Venus is the one we know least about, because the only way you can find out what's going on the surface is effectively to go there and either use radar or landers. A few landers from the former Soviet Union have actually landed on the surface and survived for a little while, long enough to take pictures, but not much longer than that, just because of the conditions being so hellish.
Okay. Well, I think that kind of answers everyone's question. There is Lawrence has asked a few questions, and I'm going to give him this one, and I think this will be the last one. Is there some way of restoring the magnetic field around Mars?
That would be geoengineering or MarsOne of the highest order. The magnetic field of Earth comes from it's an iron core, but it's two layers of it, one solid and one liquid. The solid comes about because of the extreme pressure at the center. You're talking about engineering that would be global in scale. There is no way that we can envisage how we might tinker around with the core of the Earth without doing a lot of damage along the way. And so I think the answer with Mars is no. You might, I'm sure you could generate local magnetic fields so that you could perhaps, maybe there would be some way of cocooning an area of Mars's surface with a magnetic field that might act as a shield against the radiation bombardment. But even that, I think, would be a very difficult thing to achieve. It's engineering on a scale that we have not really seen on Earth. So, a really interesting idea. But once again, another argument for, rather than taking our focus off making the Earth sustainable and the right place for us to live, that's where we evolved, rather than doing that and taking our focus away by focusing on Mars, I think we shouldn't be doing that. I think it's more about getting our own planet as sustainable and as impregnable as possible.
Excellent. Well, on that note, we will sign off. Okay. And Fred, 15 minutes to go and grab a cup of tea before he's on the ABC radio with Sarah. Is it tonight?
Sarah McDonald. It's on ABC Sydney, New South Wales, and ACT. If you're in that area, you can get it on the radio. Otherwise, you can tune in on one of the many apps that lets you join the ABC. I'll be there in about 45 minutes, talking to Sarah for maybe a little while. Some of the things I'll talk about you might have heard about already.